video is to go over notes with you about the scientific method. And I know all of you have learned about the scientific method before, so this should be a review and might be a little bit more in-depth information. The scientific method is really a process that scientists and people every day use to answer their own questions or to solve problems. You can use the scientific method formally, like we would in science class and scientists would use in the field when they're doing an experiment, but you also use the scientific method informally when you're just trying to solve problems. You usually don't think of it like you're using the scientific method. You usually just go through the steps without even knowing that you're doing it, but it really is the same thought process that you would use formally in science class or in a lab situation. So the first thing that you have to do is you have to identify the problem, or what is the purpose? What is it that you want to learn? What is your question? And it's very important when you are identifying your purpose to be specific. If your question or your problem is too vague, it's going to be really difficult to understand exactly how to test it and what it is that you want to find out. So this is when you really start to develop your question and state the problem that you want to solve. For example, if I was trying to solve, or I was trying to do an experiment about plants, maybe I wanted to know, do plants grow better in sunlight or do plants grow better in darkness? And so that maybe would be my problem. The second step, and a lot of times this is the step that people like to skip, but the second step is to do research about your topic. You find out information, you look to see if this experiment or this problem has been investigated before. You use different sources. You might use internet sources, you might use books, you might even use other people if they're experts on the topic. But you look to see if this experiment has been done before, and if so, what were the results? So you're looking up information about your question or your topic. The third step is to develop a hypothesis, and most of you already know what a hypothesis is. You're making a guess about what you think will happen or the results of your experiment. It's important that you're not just making a random guess. You're using information you already know, maybe some prior knowledge that you have, or information that you got through your research step to make an educated guess about what will happen. And it's important that you develop a hypothesis that can be tested. If your hypothesis is worded in a way that there's no way to test it, then it's not a very good hypothesis. And we always form our hypothesis using the if, then, because method. So if I go back to my plant example, I might say, if a plant is put in a closet and a plant is put out in the sunlight, then, and this is where I say what I think will happen, then the plant in the sunlight will grow taller than the plant in the closet because, and this is where I say why I think it will happen, because sunlight is needed for the process of photosynthesis. So again, you set it up in an if, then, because statement. If is what you are going to do, then is what you think is going to happen, and the because part is why you think that is going to happen. And again, that falls back on your prior knowledge and your research. Step 4 is everybody's favorite step, and this is when you actually design your experiment. And you have to make sure that you are designing it in a way that it tests your hypothesis. If it does not directly test your hypothesis, then you need to start all over again and either develop a different hypothesis or design your experiment differently. So the experiment must be designed to answer the question. And in most experiments, you have different variables. And these are the things that might change to look at your results. When you are doing an experiment, it's important that you're recording all kinds of information. These might be observations of what is going on, and a lot of times it's going to be numerical data. For example, in my plant experiment, I would be measuring my plant maybe every day or every couple days. So that would be the data that I would be collecting. I might also write down observations. Maybe the plant in the closet is turning brown. So that would be an observation that I could record. When you set up an experiment, most of the time you will have an independent variable. An independent variable is the variable that is manipulated or changed during an experiment by the experimenter that we'll test to see what happens. So it is the variable that you as the scientist control. Okay? For example, in my plant experiment, I'm putting one in the closet and one in the sunlight. That is what I am controlling. I am controlling, do they get sun or do they get dark? So that is what I am controlling. That would be the independent variable. You will also have a dependent variable, and this is what the scientist observes or measures. So this is how something responds to that change. So the dependent variable in my plant experiment would be how tall the plant grows or how healthy the plant looks. If I'm measuring height, then that would be my dependent variable. Maybe I'm just looking at how green the plant is, because a lot of times if it's really green, that means that it's healthy. So the dependent variable is in the end what you're measuring or what you're observing. This is the variable you test or measure. It's also the outcome or what happens in the experiment. In some experiments, you would have a control group or a test group. In my plant experiment, I don't really have that. This is really common anytime scientists are studying different medications. A control group might be the group that remains the same. They're not necessarily getting the material that is being tested. Whereas the test group is the group that is getting the material that is being tested. So the next step after designing the experiment and doing the experiment is the analysis or the evaluating step. And this is after you've done the experiment, you're looking at your data. You're organizing it. You're trying to determine what does this data mean. And you might do some different calculations. You might find some averages or look at median or mode. You might graph your data to get a picture representation of what your data means. You might make tables or develop pictures that represent your data. So this is using all kinds of different tools to actually figure out, what does this information tell us? What does it mean? So I might graph the height of my plants over the course of 4 weeks, and I could maybe see that the plant outside grew taller than the plant inside, and it did not grow as tall. So that would give me an idea of what does this data tell us. It's also important anytime you're using tables or graphs or anything like that, that you have proper titles and labels on those tools. The final step is the conclusion. And this is really where you wrap it all up. You look at your results, you say, what does this mean? What can I do to improve my experiment? Does my data support the hypothesis? And it really is okay if it doesn't. If your hypothesis was incorrect, that is fine. But you just have to really state, did it support my hypothesis, did it not, and maybe why? Asking why questions, this means, well, why did this happen? Why did that happen? What could be improved? What parts of the experiment could be improved? And what are some of the explanations for your results? Maybe you took the plant out of the closet one day and it accidentally got some sunlight. So maybe you had some strange data in there that might be confusing, and maybe that caused that strange data. So you might look at any variables or anything that went wrong in the experiment. I hope this helps you with scientific method.